Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Sly YouTube channel. So today in this video, we are going to see some of the common performance bottlenecks in Kubernetes. So in fact, in our previous video, we discussed about why we should monitor the performance metrics for Kubernetes. So in this video, we'll see what are the common problems or common performance bottlenecks in Kubernetes. So this, I mean, by combining these two, you will get an idea like what are all the metrics you have to collect and how those metrics will help you in solving the performance bottlenecks. Right. So before we move to this video, this is me, Vasan Shanmugam. I welcome you all to our Little Sly YouTube channel. Please don't forget to subscribe to our channel. If you haven't subscribed yet, please do join my channel and drop me a comment on your questions, or if you have any feedbacks, and drop me a like and share this video with your friends who are interested in learning about Kubernetes and in performance testing about Kubernetes. And so, as I told you, the performance bottlenecks in Kubernetes will arise from various sources and they will impact the efficiency and the stability of your applications. And here, today, we are going to discuss about the 7 to 8 common problems, common performance bottlenecks that arises out of the Kubernetes. So, out of which, the very first one, which is the resource contention. So when does this resource contention arise? So this resource contention occurs when multiple pods or containers compete for the same resources. So this is something like which we all know, a very old legacy one, which is we normally call it as deadlock. So which is where multiple pods or containers compete for the same resource. So what are the same resources? It can be a CPU, it can be memory, it can be network, or it can be a disk on a node. So what are the impact of this resource contention? So this resource contention will lead to degraded performance, increased latency, and even application crashes, because there would be like a long timeout things that would happen. And what is the solution for this? So you have to implement the resource requests and the limits to ensure fair resource allocation. You have to use node affinity and anti-affinity rules to distribute the workloads evenly across nodes. So if you do not know, or if you haven't done the node affinity and anti-affinity, please do follow my videos. I'm planning to take those sessions in the upcoming videos on how to resolve this issue in terms of the resource contention. So we'll use this, we'll do this both manual and through automatic options. So please don't forget to subscribe to the channel and please do share this video with your friends. And the second part is the deployment problems. So what is the deployment problem? So there could be issues during the deployment process, such as misconfigured resources or due to any insufficient capacity. It can cause the performance degradation. So what are the impact? So because of this deployment problems, this can lead to failed deployments, and even it can increase the deployment times and also unstable applications. So what is the solution? You have to use automated deployment tools and CI/CD pipelines to ensure consistent and error-free deployments. And also you have to validate the configurations before deployment. So as I told you for the previous one, even for this, I will give you a demo. That's more interesting. In fact, I would say, which is the automated deployment tools and the CI/CD deploy pipelines part. So that's the second common reason or the common bottleneck. And the third one is the auto scaling challenges. So if you have any improper configuration in terms of auto scaling, this can lead to either over provisioning or under provisioning of resources. In fact, we have seen this same scenario in our previous video where we were discussing about why we should monitor the metrics. So this is the same thing. So if there is any auto scaling challenges, so that's one of the common problem. So over provisioning will waste your resources, but under provisioning can cause performance bottlenecks and application downtime. In fact, over provisioning will waste your resources in terms of unwanted CPUs and memory, and also unwanted cubes, and also unwanted like you would have to pay more than what you are supposed to pay for the cloud environment. And then what is the solution? So you have to fine tune the horizontal pod scaler, which we normally call it as HPA, and cluster autoscaler settings based on actual usage patterns and performance metrics. And moving on to the fourth part, which is crash loops and job failure. So what is the crash loop and job failure? So the pods, we all know, they repeatedly gets crashed, or they will do restart, which is we don't normally call it as crash loops, or the jobs that fail to complete can consume excessive resources, and also it can affect the overall cluster performance. So what is the impact? So this crash loops and job failures can lead to resource exhaustion and degraded performance for other applications. And what are the solutions? So you have to investigate and resolve the root cause of crashes and job failures, and also you have to implement robust error handling and retry mechanisms. So that is all about the crash loops and job failures. And moving on to the fifth one, which is the network latency. So high network latency can occur due to network congestion, inefficient routing, or suboptimal network configurations. And what are the impact? So this network latency can lead to slow response times. That's the major performance bottleneck, I would say. So if there is a network latency, that can lead to slow response time. So this is across any configuration, even if it's an on-prem, or even if it's in cloud, or even if it is in cube. If there is a latency, it can lead to slow response times and degraded application performance. So what is the solution for this? You have to optimize the network configuration, you have to use network policies to control traffic, and you have to monitor network performance regularly. So that by doing all these, you can fix the network latency issue. So again, we can even do this. I can even show you how to do increase the, or how to configure the network in terms of the cube. And then the sixth one, which is the disk input output bottlenecks. So if you have high, or if you're observing high disk input output, which actually leads to heavy read write operations, and in turn it will lead to slow disk performance. So this is again a major common performance bottleneck. So if there are high disk input output, that will lead to heavy read write operation, in turn it will lead to slow disk performance, and this is another reason why we have to monitor the disk input output, and this can cause slow application performance and increase latency. And what is the solution for this? So you have to use faster storage solutions, example SSDs, and in fact even we have the advanced SSDs now. And also you have to optimize the disk usage and monitor disk input output metrics. And then the seventh one, which is the API server bottlenecks. So the Cube API servers can become bottleneck if it is overwhelmed with too many requests. So that is another way of creating a bottleneck. So you have to make sure that, I mean, like the reason is, so what could be impact? So this can lead to slow API responses and degraded cluster performance. So what is the solution for this? You have to optimize the API server performance by reducing the number of unnecessary API calls using caching and scaling the API server if needed. So the solution in simple words is you have to use caching and scaling. That's it. And then the last one, which is the pod startup time. So this is something specific in terms of the cube. So this is not something which you can see in the VM or in an on-prem setup. So when you have a slow pod startup times, that can occur due to large container images, or due to slow image pulls, or resource contention. So this can lead to application availability or unavailability, I would say, and also it can lead to affecting the performance. So what is the solution for this? You have to use smaller container images. You can use multiple smaller container images, and you have to pre-pull images on nodes and optimize the resource allocation. So by identifying and addressing these common performance bottlenecks, you can ensure that your Kubernetes clusters run efficiently and your applications perform optimally. So I would say, um, like in fact I would even walk you through each and every single bottleneck, and I will take you through like how to fix this. But there are several scenarios where you can come across this resource contention and deployment problems, auto scaling challenges, and in fact the major one is, I would say, the crash loops and job failures, because whenever the pods might repeatedly get crashed, or there might be some restarts that could happen, so that will actually lead to resource exhaustion, and also it could lead to degraded performance for other applications. So I would always advise you just go through, I mean, like just make sure you are monitoring your Kubernetes performance metrics, and make sure that you are not, you even if you get some bottlenecks, please make sure that you are fixing it before it moves to production, because that will solve lots and lots of problems in terms of any performance issues, and even in fact you will even prevent them from these kind of bottlenecks, I would say. So always make sure that you monitor all these metrics. And yep, so with that I come to an end of this video. So like I told you, I will walk you through each and every single bottleneck, and I will take you through the steps of how to resolve it. So with that, I come to an end. Like I told you, please do subscribe to my channel. Please do join my channel. You can find the link on the description, and please do drop your comments and questions if you have any. And yeah, until I meet you in our next video, it's bye bye from Vasan Shanmugam and your favorite Little Saw YouTube channel. Take care and bye bye.